Okay, Science 9, this is the second video that I promised you this week. Just one question. We're going to look at how long it takes for 18 coulombs of charge to pass a point in a circuit if the current is 24 amps. So, well, we need to figure out in this question who is our given quantities. So we are given two numbers here. We're given 18 coulombs and 24 amps. So we have 18 coulombs and 24 amps. Remember, those numbers need units. They also need quantity symbols. Coulombs is a measure of charge. Remember, a coulomb is a bucket of electrons. A coulomb is an amount of charge. Amps is a measure of current, or the intensity of current. Amps is how many coulombs pass a point in a given second. So you could also write this as 24. Instead of writing amps, you could write it as coulombs per second. That's what we're given. What are we asked to find? Look for your question words. How long? Ooh, how long does it take? So that's going to be a measure of time. So we want to find time in seconds. We don't know. And I'm actually, because this one I wanted to focus on unit conversion as well, I'm going to say how long in minutes is this going to take? So step one, we found our given and our find. Step number two, we're going to write the formula that relates these things. Well, I, current, is equal to the amount of charge, Q, that passes a point in a given amount of time, T. So I is equal to Q over T. Step three, isolate the variable that we want to find. So we want to find T, so we're going to isolate T, which means we need to put T. It needs to go on the top, and it needs to be alone on one side. So it's not on the top right now, so let's make it go onto the top. I equals Q over T. So I'm going to bring the T up here. It's on the bottom, so I bring it up. So I end up with T times I, T times I is equal to Q. After that, I can say, well, now I want, T is on the top, I want it by itself. So I need to get rid of I, which is cluttering up the T. So we're going to put I on the bottom on that side. And if we do it to one side, we have to do it to the other side. Ooh, look, I mixed two methods. I didn't mean to do that. I'm terribly sorry. I should have done the bring it on up, bring it on down, but you know what? You got half of each in this one, okay? So we now have the formula T is equal to Q over I. Step number 4, we're going to plug into our formula. So I'm going to write my formula again because I want it to be clear that T is equal to the quantity. Yeah, there we go. T is equal to the quantity of charge over the intensity of current, and the quantity of charge, 18 coulombs, divided by the intensity of current, 24 amps. Okay, we get that. And then we could rewrite current as 24 coulombs per second. So we have 18 coulombs divided by 24 coulombs per second. And the coulomb cancels with the coulomb, and that gives me a 1 there, and it gives me a 1 there, okay? So now I have 18, and then I could actually extend this all the way across, and so that would then be 18 over 24 over seconds, and dividing by a fraction is the same as multiplying by its reciprocal. So 18 times seconds over 24 is equal to, and that should be 3/4, so that's 0.75 seconds. And look, our unit, we wanted it to be seconds because we were measuring time, and it turned out to be seconds. Now, at this point, you might have finished the question, except that I asked you to find how long does it take in minutes. So now we have to do this next part of the problem, which is we need to take 0.75 seconds, and we want to find the number of minutes. And remember, when you are converting from one unit to another, we take our unknown and we say that is equal to our initial times our conversion factor. So our initial quantity is 0.75 seconds times a conversion factor. And usually in a conversion factor, I actually like to put the units in first. I know I want to cancel seconds, and I know I want to find minutes. So seconds has to go on the bottom to cancel with the seconds on the top. And I want to have minutes on the top. Sorry, I shouldn't write M is meters. Okay, and we know that there are 60 seconds per 1 minute. And I've put my calculator somewhere here. I do, excellent. So now we have 0.75 divided by 60 equals, and that is 0.0125 minutes. And let's look at our units and make sure they worked. I have seconds on the top, I have seconds on the bottom, those cancel out, and we are left with minutes. And that is it. Okay, so that is your quick little lesson on using unit conversions within the context of electricity.